a supposed comet is catching the attention of some of the nation's most renowned scientists, as one Harvard professor is raising the theory this may actually be a piece of alien technology.
3I Atlas has entered our solar system unlike any visitor we've ever seen. First spotted racing into our solar system, this interstellar object is moving at record speed and already breaking every rule we thought applied to comets or asteroids. Scientists all agree on one thing. This unidentified object refuses to fit any category we've ever defined. With its mystery comes danger. Its massive coma has grown to nearly half the size of the Sun. Its plasma layers twist in ways no natural body should, and now it glows green without the usual carbon signature. Each of these signs raises questions about whether this object could influence planets as it passes by, or unleash effects we are not ready for. So the real question is this: what exactly is hiding inside that emerald glow, and will we survive the answers it brings? In July 2025, a telescope in Chile picked up what first looked like an ordinary streak of light. At a glance, it resembled a comet, one of countless icy bodies that drift unnoticed across the sky. But as astronomers traced its path, the truth became impossible to ignore. The orbit was hyperbolic, a curve that marked it as a traveler from far beyond our solar system, here for one passage only before vanishing forever. Humanity had seen such a thing just twice before. Oumuamua in 2017 and Borisov in 2019. This time, however, was different. The new arrival, 3I Atlas, was diving deeper into the planetary system than any visitor before it, a plunge that immediately set it apart. Its speed stunned even veteran scientists. Moving at 60 kilometers per second, climbing to nearly 68 as it fell toward the Sun, it raced faster than any comet or asteroid ever measured. At such velocity, millions of kilometers vanished in hours, turning observation into a desperate chase. Telescopes and VLTS all around the world are swiveling in unison to follow its faint glow. The urgency was certain. Any delay meant losing priceless data to the darkness because the object moved too quickly for hesitation. Was this sheer gravity at work, or was there another influence guiding its path? 3I Atlas' trajectory only deepened the mystery. Instead of arriving at a random incline, as most interstellar bodies do, 3I Atlas cut almost flat along the ecliptic, the plane where planets orbit. That precision shook researchers. Unlike Oumuamua or Borisov, which skimmed past at awkward angles, this one threaded directly through the crowded heart of the solar system. To many, the route looked less like accident and more like a line carefully drawn. If it was coincidence, it was a remarkable one. Spectral studies offered another surprise. At first, the object's surface appeared coated in deep red, the weathered hue seen on trans-Neptunian bodies far beyond Pluto, colored by eons of cosmic radiation. This implied that 3I Atlas was ancient, a relic wandering the galaxy long before humans existed. Yet within weeks of its discovery, a startling transformation emerged. Observatories in Namibia captured images of the red blur shifting into an eerie green, a glow that spread across its coma like an emerald torch. It's so strange that something that looked frozen and lifeless suddenly shone with a color linked to vitality. The change shocked both scientists and the public. For astronomers, it posed a chemical puzzle without a clear answer. For ordinary people, it felt like a signal, a color too striking to dismiss. Green is the shade of growth, of energy, of symbols meant to be noticed. When an object from another star suddenly glows with that light, the imagination cannot help but run wild. From its discovery onward, 3I Atlas has refused to stay within the categories we trust. Too fast, too precise, and now visibly transformed, it stands as both opportunity and warning. If this is only the beginning, what secrets wait as it getting close to the Sun? And when the green glow becomes the world's focus, will we find nothing more than nature's trick or the first deliberate signal ever sent across the stars? On September 7, 2025, during a rare lunar eclipse, telescopes in Namibia captured an image that no one had expected. For weeks, 3I Atlas had appeared as a dull reddish blur, the kind of ancient look often seen in bodies battered by cosmic radiation. Then, in the middle of the eclipse, something extraordinary happened. The object erupted into a vivid green glow. The change was sudden, almost electric, as if the entire coma had been wrapped in a living veil of light. For astronomers used to faint, predictable comets, the scene was nothing short of surreal. Normally, green comets are not a mystery. The glow almost always comes from diatomic carbon, C2, fluorescing at a wavelength of 518 nanometers. This is a familiar signal, a reliable piece of chemistry repeated again and again as the asteroid's moving closer to the Sun. But the problem with 3I Atlas was clear. Spectral data collected before the eclipse had shown almost no C2 at all. The expected building block for the glow simply wasn't there. That left a gap in the explanation, a hole that normal comet science could not fill. Some research groups argued that carbon dioxide inside the object could be breaking down in unusual ways under solar radiation, producing an unfamiliar emission. Others pointed toward plasma as the culprit. Around 3I Atlas, instruments had already detected complex electric fields layered like double shells. Within such an environment, interactions can trigger rare emissions, and sometimes those emissions show up as colors not seen in ordinary comets. If this theory was right, then the glow was not chemistry at all, but the visible trace of electromagnetic forces at work. Beyond the science, the symbolism of the color struck a chord. On Earth, green is inseparable from life, the shade of plants, renewal, and energy. It is also the color of auroras, lights that speak of the Earth's own link to space. To see that hue blazing from a visitor beyond the stars turned the discovery into a global conversation. News outlets described it as the Emerald Beacon, while social media exploded with speculation. Memes, videos, and amateur captures spread across platforms, pulling millions into the story. The glow became something more than just an astronomical event. It became a cultural moment. Scientists, meanwhile, wrestled with their own doubts. The glow was too sudden, too dramatic, and too neatly timed with the eclipse to be ignored. If it was natural, it pointed to physics that had never been catalogued. If it was not natural, then it carried the unsettling weight of intention. Either way, every image arriving from observatories deepened the unease. What had looked like a silent fragment of rock now seemed to be performing, as though the universe itself had switched on a light to demand our attention. From that night forward, 3I Atlas was no longer just a reddish blur moving across the sky. It had become a green flame in the dark, a question written in color. Was this the fingerprint of exotic chemistry, or the simplest kind of signal designed to be seen across the void? And if a mere change of color can shift how we see the universe, what other impossible surprises will this interstellar visitor reveal as it approaching closer? The green glow may have captured the headlines, but it was only the beginning of a deeper puzzle. As astronomers tried to classify 3I Atlas, they ran into a problem. It did not belong anywhere on their charts. Was it a comet stripped of ice, an asteroid disguised by dust, or something entirely new? The first polarization readings, gathered through July and August 2025, painted a picture no one expected. Instead of scattering light like familiar small bodies, 3I Atlas bent it in ways that looked engineered, almost like it was wrapped in a plasma shell. Instruments even revealed double electrical layers, stacked fields that scientists usually only see in controlled laboratories, not drifting through deep space. The idea that a wandering rock could carry electromagnetic structures so complex was unsettling because it blurred the line between natural and artificial. Even the matter of size remained unsolved. Estimates for its nucleus stretched from a tiny 200 meters to a massive 50 kilometers across, a margin of error so wide it left scientists uneasy. If the smaller figure was right, then the brilliant coma of plasma was exaggerating the presence of an otherwise insignificant fragment. But if the larger estimate held true, then humanity was staring at an intruder large enough to unleash catastrophic consequences if its path shifted. The difference between pebble and planet-sized was not academic, it was the difference between a curiosity and a threat. Every new observation tightened the tension as researchers wondered what they were really dealing with. A paper released in August 2025 pushed the discussion into even stranger territory. The authors proposed that 3I Atlas might represent an entirely new class of small body, one that forced a rewrite of how we define asteroids and comets. If such bodies existed, the solar system might be surrounded by millions of them, passing silently until one appeared close enough to be noticed. For scientists, the idea was both thrilling and terrifying. Thrilling because it meant the universe still had surprises waiting. Terrifying because it meant our neighborhood in space was far less predictable than textbooks suggested. The comparisons to earlier visitors added weight to the mystery. Oumuamua in 2017 had defied logic with its elongated shape and lack of coma, while Borisov in 2019 had looked more like a classic comet but carried chemistry that seemed alien. Now came 3I Atlas, which appeared to combine their contradictions and then add new impossibilities on top. It had the strange orbit of Oumuamua, the exotic chemistry of Borisov, and plasma structures neither of them ever displayed. For researchers who had lived through both debates, this object felt like a test the field of astronomy was not prepared to pass. Each interstellar visitor seemed to raise the stakes, and this one raised them higher than ever. As if that were not enough, later observations revealed a tail behaving in ways no comet tail should. Instead of streaming away from the sun, driven by radiation pressure and solar wind, the tail of 3I Atlas pointed directly toward it. At the same time, the plasma surrounding the body pulsed in steady rhythms, almost like the beats of a transmitter. Some compared it to a radio signal, a pattern that implied control rather than chaos. The suggestion alone sparked fierce arguments, because if nature had produced it by chance, it was the rarest accident imaginable. And if it wasn't chance, then the implications were even more staggering. By the end of September 2025, what began as a faint streak of light had become the most controversial visitor in modern astronomy. Every new measurement raised more questions, and every anomaly pushed it further beyond natural explanation. For some, the object forced a chilling realization. Maybe the universe is not as neatly divided into categories as we want it to be. For others, it hinted that engineering could be hiding inside what looks like nature. If 3I Atlas keeps breaking every definition we hold, then what secrets might still be waiting inside its expanding coma? And when the last data finally arrives, will science explain it as a masterpiece of physics? Or will we be forced to confront the possibility of advanced technology crafted by a civilization beyond our own? One of the most striking mysteries of 3I Atlas lies in its plasma structures and the colossal coma that surrounds it. A vast envelope of charged particles expanding and behaving in ways no natural body should. Between July and September 2025, this coma swelled to nearly half the size of the Sun, transforming from a faint blur into one of the largest visible structures ever recorded in the solar system. This was not the thin fog of gas and dust expected from icy bodies near the Sun. Instead, it displayed layered patterns, concentric rings that looked more like engineered walls of electricity than anything nature was supposed to build. Plasma physicists recognize the resemblance to double layers, structures usually produced under controlled lab conditions, but now playing out on a cosmic scale. The mystery deepened with chemical analysis. A James Webb Space Telescope study led by Martin Cordner, a physician researcher at NASA, found that the gas coma was dominated by carbon dioxide, with a CO2 to H2O ratio nearly 8 times higher than that of typical long-period comets. That meant 3I Atlas was venting CO2 in proportions rarely seen, hinting at a nucleus rich in exotic ices forged under conditions far different from our solar system. A second investigation by NASA's SphereX team reported strong water ice absorption, but concluded that over 99% of the light detected came not from the nucleus, but from coma dust. In other words, what we were seeing was not the object itself, but the vast, unstable atmosphere it carried like a cloak. For some astronomers, this only raised the stakes. Adina Feinstein of Michigan State University noted that every interstellar visitor observed so far has been unique, but 3I Atlas may be the most revealing yet. Its plasma coma provides a natural laboratory, a window into the conditions of distant planetary systems where CO2 ice lines form. But others, like Harvard astrophysicist Avi Loeb, have taken a different view. Loeb points to the object's strange geometry, including its tendency to project light and material sunward rather than away, as a sign that the coma might not be entirely natural. When a comet defies the pressure of the solar wind, he argues, we should be open to explanations that go beyond standard models. The coma also flickered. Instead of glowing steadily, its brightness rose and fell in pulses, sometimes as if it were breathing in the dark. Plasma can self-organize into rhythmic structures, but the regularity unsettled researchers. A few dared to suggest it could act like a plasma antenna, amplifying and radiating electromagnetic waves. If true, every flicker might carry information, light behaving as signal rather than background. Karen Meach of the University of Hawaii reminded her colleagues to stay cautious, warning that with only 3 interstellar objects ever studied, even wild coincidences can appear meaningful. Yet the unease remained, because the coma of 3I Atlas seemed to be following rules of its own. Solar scientists warned of the risks. A plasma envelope this large could interact with the sun in unpredictable ways. Some simulations suggested an increase in solar flare activity as 3I Atlas reached perihelion at the end of October, raising fears of X-class storms that could ripple across Earth, damaging satellites and power grids. The timing felt ominous, a massive interstellar intruder arriving just as the sun was entering a volatile phase of its cycle. By now, few scientists still see 3I Atlas as a simple comet. Others described it instead as a system, a structure, even a potential machine. Each new observation only added to the feeling that the coma was more than decoration. It was a stage where unknown physics, or perhaps something more deliberate, was unfolding. And that left a question hanging heavy in the air. Is the vast plasma cloak of 3I Atlas simply a cosmic coincidence, or are we witnessing the signature of a power designed to make itself seen? Among all the strange signals coming from 3I Atlas, one in particular has left astronomers staring at their charts in disbelief. Polarization curves, the fingerprints of how dust and gas scatter starlight, usually follow familiar patterns. Yet in this case of 3I Atlas, the lines broke away from every rule, forming shapes no comet had ever produced before. To the experts, it was as if the object itself was rewriting the script of how light behaves in space. When astronomers measured how light reflects off 3I Atlas's coma, they found that the flip point, the moment polarization changes direction, occurred earlier than in typical comets. The depth of negative polarization was stronger too, bending light in ways that textbooks had never prepared us for. Avi Loeb, an astrophysicist best known for his work on Oumuamua, argued that this combination does not match any known asteroid or comet, and it stands apart even from earlier interstellar visitors like Borisov. Karen Meach, one of the world's leading comet specialists who has studied both Oumuamua and Borisov, interprets the data differently. She believes the strange polarization suggests the coma of 3I Atlas is laced with a blend of dark organic dust and volatile ices in rare proportions. That unusual mixture could explain why the object's light scattering looks so alien, and why its coma particles might be rougher and more irregular than those of solar system comets. Other astronomers see parallels with trans-Neptunian objects, the frozen worlds that drift in the far edge of our own system. The early red tint of 3I Atlas, later followed by a shift in strange polarization, mirrors traits of those distant bodies. If true, it may mean this object formed in a cold, remote environment around another star before being ejected into interstellar space. But the debate is fierce. Some experts, including Loeb, are open to more radical interpretations, suggesting that the anomalies in polarization could hint at exotic physics, or perhaps even the possibility of a structured, engineered body. Others urge caution. Many experts in the comet community emphasize that comets often produce surprising polarization when observed under unusual angles or extreme heating. Breaking records, they say, doesn't necessarily mean breaking nature. At the University of Maryland, Lyudmila Kolokolova, who has spent decades studying light scattering by cosmic dust, noted that deeper negative polarization often points to complex or porous grains. To her, 3I Atlas is a reminder that dust in space can behave in ways we still don't fully model, especially in an object exposed to radiation it has never encountered before. So far, polarization tells us about surface texture, particle size, and composition. For 3I Atlas, those clues point to rougher grains, darker material, and dust interacting with light in unpredictable ways. Compared to Borisov and Oumuamua, this visitor doesn't just add one new twist, it combines anomalies from both and amplifies them. Which leaves us here. Polarization doesn't just stretch the definitions we use, it threatens to erase them. Will the final dataset force scientists to redraw what it even means to be a comet, to admit that our categories of rock, ice, and dust are too simple for the universe we live in? Or will 3I Atlas mark the moment we realize some visitors cannot be explained by natural physics alone? October 3, 2025 is marked in red across observatories worldwide. Mars lies directly in the path of 3I Atlas. For space agencies like NASA and ESA, this presents a rare chance to peer into the nucleus of an interstellar object in close proximity for the first time. Instruments aboard the Mars Reconnaissance Orbiter could capture images of unprecedented resolution. Yet that opportunity carries risk. The object travels near 68 kilometers per second, and even a tiny shift could cause unexpected gravitational or plasma interactions near Mars. A miscalculation could mean more than a scientific miss, potential planetary hazard. Astronomer Avi Loeb warns that the highly aligned trajectory with Mars and the ecliptic plane might not be purely accidental. He speculates that under certain hypotheses, 3I Atlas's close approach could reveal whether its behavior is natural or suggestive of engineering. Yet many experts disagree. Scientists at NASA and other observatories emphasize that to date there is no evidence pointing to non-natural origins, and that all observed features still fall within extreme but natural cometary or interstellar object behavior. Looking ahead, the perihelion on October 29, 2025, a moment when 3I Atlas passes closest to the Sun, is expected to be key. Observations from JWST reveal that the coma is dominated by carbon dioxide with high CO2/H2O ratios, and that outgassing increases deeper in the Sun's grip. A physicist from NASA has noted that this period could show whether non-volatile ices or heat-shielded interior layers influence the object's reaction to solar heating. These behaviors could affect solar activity or particle emissions in surprising ways. Meanwhile, models comparing the object's dynamics place its origin in the galactic thick disk, suggesting it is billions of years old and has survived harsh interstellar space. Matt Hopkins and other astronomers working with the Otautahi Oxford Interstellar Object Model estimate 3I Atlas to be 7 to 10 billion years old. That kind of age suggests it has survived extreme radiation and erosion, leaving its core either dangerously fragile or surprisingly tough. Then there's the public concern. Harvard's Loeb has argued that extreme hypotheses, such as that 3I Atlas could be alien-engineered or even hostile, are worth entertaining, not as conclusions, but to guide observations and readiness. He warns that if the object behaves anomalously when near the sun or when hidden behind solar glare, humanity could miss critical data. On the other hand, other scientists caution that while the theories are provocative, extraordinary claims require extraordinary evidence. To them, alarming as it is, all current measurements still fit natural explanations. The opportunity here is tremendous. This close passage near Mars, the Sun, and later Jupiter offers multiple vantage points. Our interplanetary spacecraft already in the region, such as those orbiting Mars or on path to Jupiter, could intercept data from dust, plasma, or tail material. Such data could illuminate the internal structure, composition, and even interaction dynamics of 3I Atlas in ways impossible from a distance. So the stakes are high. This is not merely an observational event, it is a turning point. Will humanity treat 3I Atlas as a threat to guard against, or an opportunity to study something far outside our past experience? When all the data from Mars flybys, perihelion observations, and beyond are finally in, will we look back and see a triumph of astrophysics, or be forced to rethink what objects from beyond our system can do? 3I Atlas is not just another rock passing by. It has forced us to look at the sky with new eyes, breaking every rule we thought we knew about comets and asteroids. Its speed is beyond belief. Its plasma halo is alive with strange rhythms, and its sudden green glow feels like a signal meant to be seen. Every observation leaves us with more questions than answers. Is this the product of violent cosmic forces, or the work of something far more intentional? Could it be a natural time capsule drifting between stars, or a machine carrying a message across light years? What makes 3I Atlas unforgettable is not just its mystery, but the choice it gives us. We can dismiss it as coincidence, or we can treat it as an invitation. If the universe is speaking, are we ready to listen? And even braver, are we ready to answer back?